Okay, so question 1A here, this is similar triangles, is asking what makes those three triangles similar. And this is a good question because it helps us get started on solving the problem. Does anybody know what the answer to the question is? Thomas? Like the question A, why are the following triangles similar? Yeah. And what does that mean if they have the same symbol? Same angle, and it's got two of them the same. Those two are the same. Those two are the same. And if two are the same, three are the same because they have to add up to 180, something we've talked about. And so they're similar triangles because they have three equal angles. And like I said, that's useful to get started because you can set up the whole problem by starting with finding angles that are equal. So angle A is equal to angle D. It's not always alphabetical, right? Angle B is the open space, so that's equal to F. And angle C is equal to angle E. So I did ABC alphabetically, but DFE, I looked at which angles were equal to figure out the order for that. Then we can do this. Triangle ABC is similar to triangle DFE. Then I take AB and DF, and I say side length. A lot of people do this and they don't really know what it means. They just write it and it kind of ends up working, but then we get confused in some other circumstances. What does AB mean? It means the length from A to B. It's this distance. So that's going to be 11, right? It's a line segment and it's a length. So A to B is over D to F is proportional or is equal to BC over FE, which equals AC over DE. Then I go and find all the measurements. So we already talked about how AB is 11. The whole point of all of that pre-work is to get this statement we're about to write. If you could go straight to this statement, that would be fine. DF is 12. BC is 8. FE is Y. AC is X. And DE is 16.5. So if some of you already started this question, check that step and make sure you got every part of it right. And if you do, very good. What was I going to say? Oh, if you skip this part, it is easy to make a mistake with that because you don't know which side lengths go with which. You can't switch that up. It's got to be done the right way. So because this one is rotated compared to that one, people will kind of guess and get this step set up the wrong way. So just be careful. But some people are good at visualizing that, and if you're one of those people, then that's fine. You might be able to jump straight to this step. Okay, so now I need to set up two proportions to solve. One to solve for y, one to solve for x. So I'm going to pick x over 16.5 equals 11 over 12. So I picked the one with x, and I picked the one that has two numbers. So I have an equation that only has one variable. And then the other one, watch what I'm going to do. I'm going to say y over 8. So see how I flipped that one? I have to flip the other one as well. You could do that in two steps, or you could write it straight like that. But notice I've got 11 over 12 in one case and 12 over 11 in the other, but that's because of the variable. You want to eventually get the variable on top anyway. Multiply both sides by 16.5 in this case, and I'm going to multiply both sides by 8 in this case, right? And my answer is one step, 11 times 16.5 divided by 12, and x, I'll round this to one decimal place, is 15.1. No units, but if there were units, centimeters or something, I'd have to include those. And this one is 12 times 8 divided by 11. 8.7 units. Everybody good? Okay, one more. Why are the following triangles similar? It's the same idea. I don't want to get into that too much. This is the trickier one, but let's start it out the same way. So what are my two triangles? I'm not going to write them in the right order here. I'm just going to identify them. One of them is ABC, ABC. The other one is A to D to E back to A. So the other one is A, D, E. So I want to figure out which angles from one of the triangles equals which angles from the other. So obviously A equals A. What does B equal and what does C equal? B equals D because they're both right angles. And C equals E. We could use geometry properties to figure that out, or you could just realize that it's the last angle. So they have to equal each other. That means triangle ABC is similar to triangle ADE. And it means AB over AD equals BC over DE equals AC over AE. Start subbing in. A to B is 11. What's A to D? Thomas? 37. Some people would put 26 in there just because they're in a bad habit of sticking numbers into, wherever they fit in closest instead of thinking about what AD is. It's the length from A to D. And if this is 11 and this is 26, the whole way must be adding them together, right? Okay, BC, let's see, is 8. And DE is Y. A to C is X. And A to E is X plus 45. So this is the really tricky kind where you have X and X plus 45 in one of them. So if I was going to go solve Y, that would be easy. It'd be Y over 8 equals, or again, flip it, 37 over 11. So Y will equal 37 times 8 over 11. I'm just going to do this quickly. 37 times 8 divided by 11 is 26.9, rounded. How about this other one? So first of all, I'm going to flip it and put X plus 45 on top. So X plus 45 over X equals 37 over 11. And what am I going to do? Anybody have an idea? Any kind of guess or anything? I'm going to multiply both sides by all the denominators. So I'm going to multiply by X and by 11. So the 11s are going to cancel on that side, and the X's are going to cancel on this side. I'm going to be left with something like this. Distribute the 11 through. 11x plus 45 times 11 is 495. 37x. Subtract 11x, subtract 11x. And you get 495 equals 26x. 495 divided by 26 is 19.0. Any questions?